Hi everyone. In this video, I want to show you a quick demo about Cloudera DataFlow function, where the use case is to run a NiFi flow as a function. The function will be checking the contents of a table in a database, and then would send the data over an HTTP endpoint. In my case, I'm going to provision Postgres database in AWS. My function will be checking this, and the data will be sent through Slack API callback. So there will be an HTTP endpoint that I will be calling, sending the data over this and get the data into Slack. This is a very easy use case, and the trigger will be a cron. So I will be just executing my function every 5 minutes. This is a very simple use case, but hopefully it can help you get a better understanding of what Cloudera DataFlow Functions is about. In the description of this video, you can find a few links redirecting you to the documentation we have to explain what Cloudera DataFlow Functions is, and also how to get started. So you have a quick start with another use case that you can easily get up and running on all 3 cloud providers with AWS Lambda, Azure Functions, and Google Cloud Functions. In this case, for this specific use case, I will be using AWS. You can find very detailed documentation on how to create your first function and all of the features and configuration we are offering to you. And hopefully everything is self-explanatory so that you can get up and running with your first function. Okay, so let's get started. Let me show you the flow that we are going to run as a function. So this is my flow. Every function is always starting with an input port in NiFi. So that's the first step. The input port is used by our framework to inject the data that is going to be provided by the cloud provider when the trigger is happening, when the event based on the trigger you are defining is going to happen. In the case of the cron, like defining a cron and the function is executed based on this cron, the contents of the flow file that we are going to inject in the context of AWS is just going to be a small JSON payload containing very basic information about the cron that you defined. We will see what the content is when the function will be running. The next step is just to decide whether or not we want to log the content of the flow file. This is something completely optional, and I make it parameterized so that's based on the parameter log payload. I can decide whether or not I want to log this payload. This is useful for debugging when you get started with Cloudera DataFlow Functions for the first time. In production, you will not be using this. You will remove this. You will not be logging the payload. Then I'm routing based on the cloud provider on which I'm running. But in this case, there is no, let's say, processor that is specific to a cloud provider. So for all 3 cloud providers, I'm going to use the same sequence of processors. If you had some differences between cloud providers, you may want to have specific processing. The first step is going to execute a query against my database that I set up. So in this case, execute SQL record. I'm going to execute a SQL query that I define as a parameter. I'm going to write results as JSON. And in the connection pool, I have Postgres that is being used, but everything is parameterized. So the JDBC connection string is a parameter. The driver class name is a parameter. The driver location is also a parameter. User and password are also parameters. So everything is parameterized. So that's my execute SQL record processor. Then I'm splitting records. Each record is going to be a flow file. So each line in my table is going to be a single flow file. The reason is that I want to replace the record, the data that I retrieved from the database into this specific format, which is what is expected by Slack when sending data over HTTP with the webhook. So this is just a replace text to put all of the data that I retrieved from my database into this JSON. And just before, in the split record, I decided to convert from JSON to CSV, just because it's better. It's easier to visualize the data as CSV for data coming from a database when sending it into Slack. And then I'm using the invoke HTTP, very easy post requests with the HTTP endpoint that I'm getting from Slack. Same, I define it as a parameter, and that's it. That's all I need. I don't need a success output port because there is nothing I want to send somewhere. Everything is terminated. I'm just configuring a fader output port just to make the function as a fader in case there is something wrong happening when executing my function. That's all. That's all I need to do. So if I go one step up, this is my process group in which I created my flow. We can look at the parameters. I created the parameter context with this name. I have all of my parameters, the database parameters, the SQL query, the log parameter, and the HTTP endpoint. I don't need to set values here because all of this is going to be defined when I'm configuring my Lambda, and that's it. I can right-click. I can download the flow definition with or without external services. Doesn't matter in this case because I'm not referencing any external services. So you can download the flow definition. It's going to give you a JSON file. And then once you have this JSON file, you can go straight to Cloudera DataFlow in public cloud. So in this case, you will go to your catalog. So this is something you have access to when using Cloudera DataFlow in public cloud. You will go to your catalog, which is kind of an NiFi registry to store and version your flows. And I already uploaded my function here. So this is already available here. You can upload it. You can upload new versions. And when you have your version uploaded here, you are provided with a CRN for your function, for your flow definition. So this is something important because we will need it. We will this information to configure our Lambda. So copy paste this value, and it will be required when you create your Lambda. Be sure to select this one, which contains the version number, V8 here, because if you select this one without the version number, the function won't be running. We are expecting the version to be specified so that when the function is running, we exactly know which version we should be retrieving and executing. That's it. One last thing is to go into management console and then user management. You want to create a service account with the specific DataFlow Functions user role, and you want to create credentials to have an access key and private key for your user. That's also something you will need when configuring your function. Everything here, all of this is explained in the documentation. So feel free to have a look in the documentation if you need more guidance around this. That's all we need to do. Then we can go directly into AWS. So here you can see that I created a database. It's a very small one in the free tier of AWS. It's a Postgres instance. Nothing specific to mention about the database. I created the database. I added a table. I added a few records in it. That's it. That's all you need to know about this database. Then I'm going to my Lambda. I'm sorry, but the name of the Lambda is completely misleading. This is not about resizing image. This is really about getting data out of a database and sending it over HTTP to Slack. This is because I reused an existing Lambda, so please ignore this. Very, very quickly, but all of those steps are very well described in the documentation. You would upload the binary that we provide. You will configure a few things. So the binary is something you retrieve from the Dataflow control plane. If you go in functions, you can download the binary for AWS Lambda. It will give you a zip file. You will upload this zip file into an S3 bucket, and then you will be able to configure all of this when creating your Lambda. Something that we will be needing is to have a layer to provide the Postgres driver to NiFi. So you need to create a layer. Here we can see it. So to create a layer, it's easy. You just take the driver, you add it into a zip file, you create the layer, you upload the zip file, and that's it. That's all you need to do. I can show you if you want. Add a layer. You would create a new one. So you will say custom layer. You would create a new layer. So you will give a name. You will upload the zip file or reference a file that is already in S3. You would choose x86-64 for the architecture. For the runtime, you would choose Java 11, but you can also choose Java 8 if you want. And that's it. You create it, and then you can reference it. So here you would say custom layer. You would select your layer, the version of your layer, and that's it. And you would add it to your Lambda. So in this case, I have my layer added. That's it. Then you can go directly to the configuration and go to general configuration. Just a couple of things. In memory, you probably want to increase this a bit. You can set 1 gig. I think in this case, we don't need that much. Like if I look at my executions here. Yeah. So here we can see that we are using less than half a gig. So you could decrease by quite a lot. You could decrease by quite a lot the amount of memory being used here. For the duration, 5 minutes is a good value, because when there is a cold start with NiFi, it can take like half a minute to start everything. But then depending on what your function is doing, you may want to make sure there is a large enough timeout to make sure your function is not going to be killed. 5 minutes is way too much for this use case, but it's not a big deal if you set a too high value. That's it. Then in the environment variables, here you can see that I configured all of my parameters except a couple of parameters that are sensitive and that I configured in AWS Secret Manager. So here you can see it's just, you can add just key values with the name of the parameter and the value you want. So for example, in this case, that's my JDBC string to access my database, the class name of the driver, the location of the driver. By default, when adding a layer, the data is going to be mounted into /opt. So I'm just referencing /opt/ the name of the jar file that I added into my zip that I used as a layer. My DB user, then DF access key and private key are the credentials of my user that I'm using to access the Dataflow catalog. The flow CRN that I was mentioning before, the failure port, just to tell the name of the output port I created in case of failure. I'm saying that I want to log payload. Output ports could be removed because I don't have one. The SQL query I'm executing, which is in this case select star from phonebook, but you could use you could execute whatever SQL query you want. And the Nexus URL is something I use to override the default, so that all of the nars that are required for executing my flow are downloaded from the open Maven repository. You don't need this value in most cases, because by default, you would download the nulls directly from the Cloudera Maven repository, which is perfectly fine. So this is just something I did on my side, but you would likely not do this at this value. For the sensitive values, if you go to AWS Secrets Manager, you can create a secret. Give the secret the name of the parameter context you created in your flow. So that's, from a configuration point of view, everything is out of the box, done for you. So I created a secret with the same name as my parameter context in my flow. And then I added key values for my sensitive values. So the database password and the HTTP endpoint for my Slack webhook. So both are stored as secrets here. And that's all. You just need to make sure that in the permissions and the role that you are creating for your Lambda, it has read access to your secret. So for example, in my case here, if I open the policies that I have for the role of my Lambda, we can see here that I have read access to my specific secret. So we can see here that I gave read access to my secret. So all good, and NiFi will know how to get the right values. That's it. And then you can publish a version. So action, publish new version. I already have one published. And then what I'm doing is to add the event bridge trigger, which in this case is allowing me to do a cron-driven trigger. So you would say add trigger, you would select event bridge, you will create a new rule if you want to create a new one. And here you will say, if you want 5 minutes, you would say something like this, wait 5 minutes. In my case, I already created this rule, so it's every 5 minutes, and that's it. You can add. I already did it. So you can see here in triggers, I already have my every 5 minutes configured. So my function is going to run every 5 minutes. If we go in the monitoring, we can see it's been running already a few times. And we can see that the first execution took about 30 seconds. That's the cold start I was mentioning about. We have some documentation here explaining what is a cold start, what is happening. All of this is explained here, how you can reduce it and so on. So that's something important to keep in mind. But you can see that once we had this first execution, then the subsequent executions were always below 1 second. So the function accessing the database, getting the data out of the database, and sending the Slack notification with the content of the database, all of this was executed below 1 second. Okay. If we look at the logs, it would look like very classic NiFi logs. So here we can see that we received an event, and in my case, I'm logging the information. So if I was going to run this in production, I will switch off the logging so that we are not doing this. But in this case, I'm logging the information. So the flow file that we are injecting in the input port with the data provided by the cloud provider is containing those attributes. So we can see a lot of information like the RN of the Lambda. We can see a few things, like very interesting things. The cloud provider is something we provide, so it's running on AWS. And here is the actual payload that the cloud provider AWS is giving us with this trigger. So we can see that it's been a scheduled event with a specific time in a specific region, and it's based on the specific rule every 5 minutes that I created. That's really everything that AWS is giving us in a JSON payload. There is nothing really useful, to be honest. So if you have a function that is cron driven, you would use the input port and the flow file that we inject in it as a way to like trigger the subsequent processors, but it's unlikely that you will need to extract any data out of this payload. So that's why we are not doing any of this. We are going straight to the execute SQL record processor, and we execute the SQL query to get the data out of the database. That's it. And if we go to my Slack, in this case, nothing really interesting, but every 5 minutes we can see that I'm receiving the same 2 records every 5 minutes. So in this case, I'm just sending 2 lines over Slack, over HTTP as a Slack notification in a specific Slack channel. And it's every 5 minutes, it's the same data. So we should receive like any second now, we should receive 2 new lines, because those 2 lines were 5 minutes ago. So let's wait a few seconds, but we should see two lines coming with the same data. Something that could be more, let's say, real life, like a real life use case, will be to use a query record processor in the middle, so that we can filter out records that we retrieve from the database based on some specific rules you have, and then decide whether or not you would like to trigger this HTTP endpoint. So you could check every 5 minutes the content into a database that is maybe representing some business status, and based on what you see, you would decide to trigger or not this HTTP endpoint. So yeah, we noticed that we received the two lines, and that's really what the function is doing. So I will just go back here, and if we go into the metrics, we can see that everything is working as expected. Here we can see the first one took about 30 seconds, but then the next execution were below 1 second. No error, everything is delivered on time, nothing specific to mention. As I said, we are provisioning too much memory. In this case, we could change the configuration to just use half a gig, and that will be enough. That's it for this use case. Hopefully, it gave you a good understanding on how to configure a cron-driven function in AWS Lambda to execute NiFi flows. Thank you for watching, and see you next time.